Yes, good afternoon, students. All right, I think I have enough students to actually start now. I will be touching, reviewing, or looking at electricity and lightning now. I would have touched it in some way previous school term. So as for lighting, and definitely electricity is what we are looking at. The notes. The notes, I think I would have posted the notes already, but I'm still gonna repost it so that those persons who do not have the notes, they can, of course, get access to it. I trust and hope that everybody is doing well. Right, so lightning and electricity, relate to electricity definitely. All right, so electric current. So we're talking about electricity. So first and foremost, living organism on Earth are made up of small particles called atoms. So this slide is to basically give you insight of basically the concept in terms of electricity. Now, once you're looking at electricity, definitely these two terms, conductor and insulator, they must be paid keyed attention to. And that is simple because once you're looking at electricity, then definitely there will be times whenever we don't want electrical current to actually pass through a particular material. As let's say, for example, you're in an environment where there are a lot of kids, a lot of small ones, and there's electricity within that vicinity, then definitely we want to reduce as much as possible exposure in terms of wires or cables that definitely that will have some form of electricity in it. So that simply means that we would be focusing on definitely conductors and insulators. Insulators, for example, if you don't want the electricity to pass from one object to another. So as for conductors, as it relates to electricity, these are normally materials that will allow electricity or allow electric current to actually pass through them. What that simply means is that if you're looking at a piece of wire or a piece of metallic object and you should attach one end to an electric source and attach the other end to another object that will need some electricity. I'm sure that it will actually work in terms of turning on, motor starting, light bright up, simply because you would have been using something that is referred to as a conductor. So a conductor definitely is any form of material that can allow electrical current to actually pass through that object and definitely being passed on to another object. Of course, we have some materials that are excellent in terms of moving electricity from one place to another. Copper, well commonly known, and definitely aluminum. So these are said to be excellent conductors of electricity. Now you will realize that basically all electrical cables, all electrical wires, they are made from copper, some form of copper, and that is simply because copper definitely has that ability to transmit or transfer large amount of electrical current. Now, along with copper, they are saying that aluminum are also excellent conductors of electricity. So again, we're looking at electricity in terms of being able to move or being able to not move. So first, we're saying that the conductors, what are known as conductor, these are normally material. These are things that allow electric current to pass through. So let's say, for example, you have a piece of board being attached to an electrical current at one end and it is attached to something else metallic at the other end. Then once there is a conductor, once there is electricity, then no electrical current will pass through, and that is definitely because that piece of wood wouldn't be a good conductor. So aluminum, excellent. Copper, excellent. These are normally used to make electric wires. So they are saying that when you look at electric wires, they are mostly made from copper and definitely aluminum. The JPS cable that they run in the air wire, it is made up of aluminum. Right, aluminum is what made those JP twisted wire. Now, after looking at conductors, and definitely again, conductors are normally materials that allow electrical current to pass through. Right, so insulators, total opposite. So these materials do not, as you can see, do not allow electrical current to pass through them. And we have several reasons for this, several reasons. Electricity cannot pass through because their electrons are not able to move around freely. Rubber, plastic, dry wood, paper, and of course glass. So definitely all these would say that these are definitely insulators. Definitely insulators, because let's say for example you're attaching or you're joining two different pieces of wire or cable, you will realize that you will, after you join them together, you will basically tape that section that you would have joined, and that is simple because you're now using rubber, so you're using something where the person cannot get, where the person cannot allow electricity to pass over. So those are the examples: plastic, rubber, wood, and of course you'll realize that they said it is a dry wood, because the green one definitely will cause it to move simply because it contains water. Alright, so after looking at insulators and conductors, as for electricity, we're looking at something that is called electric circuits. So we're basically gonna look at how electricity moves through the human body. So first thing, we're gonna look at what is called, or what is known as an electric circuit. In order for an electric current to flow, there must be a complete path around which the electrons can travel. Very important information. So in order for an electric current to pass through, there should be a complete path around which the electrons can travel. This complete path is called an electric circuit. So an electric circuit, the current definitely must flow, and there must be a complete path, meaning that it basically make a circle. So We have a simple basic one on the screen here, where you have definitely the bulb, so that's what's going to light up. You have a battery, and once you're looking at electricity, you will need definitely a good power source. hmm And then you have the switch. So there's an on and off key or on and off button on the switch. So once it joined to the bulb, it joined to the switch and joined to the battery, then we would say that the circuit now is complete. Definitely complete. Alright, so an electric circuit needs some different things. An electric source, such as a battery, such as a cell, or our main electricity. An appliance such as a lamp and of course TV normally have connecting wire to link the different components in the circuit and provide a complete path for the electricity. Alright, the energy available to drive the electrons around the circuit is referred to as the voltage. Voltage, very important. Most circuits contain a switch to regulate the flow of electric current. So that is for most circuit. Right, so most circuit there's a switch on it, and the switch will now regulate it by clipping it on and off. So if there is no circuit, then definitely you will have to do it manually if there is no switch, I should say. When the switch is closed on, the lamp will light up as the circuit is now complete. To allow the flow of electrons. Alright, so when the switch is closed on, and that means it is on, the bulb will light up as the circuit now complete to non-complete along the flow of electron. When the switch is open, and that is off, the circuit is considered to be broken. So looking at the switch now, so the black section that you're seeing there, the switch seems to be open now. So you're not going to have any light coming to the bulb unless that black section, the switch is now closed. This prevents the flow current through the circuit. So if there is no switch, then continuously the device will be powered off. But because it is very important for in terms of overheating of the device, so there must be a switch so you can turn it on and turn it off manually. Alright, so as for the circuit, we have different types of circuit. We have series circuit. So all components are connected together in one loop, I should actually say. So it connected in one loop, so all the components. So we're looking at the image now. You're seeing 3 bulbs. So the 2 blue wires coming from the cable. So this is what we call a series circuit. They really look uniform. Really look decently uniform there. As for the series circuit now, if one of the component becomes defective or disconnect, no electric current will pass through the circuit. So here we have two images just showing you, top one showing you series, bottom one showing you what is known as peripheral connection. And as for the parallel circuit now, in a parallel circuit there is more than one route through which current can travel around and back to the battery. So when you look at the diagram, the parallel circuit a bit more sophisticated than the series one. So here we have two bulbs. So one end of the bulb is attached to this cable that is attached to that circuit board like. So in a parallel circuit here there is more than one route through which current can travel around and back to the battery. So the current now, the electricity is split up to supply each branch of the circuit with electricity. The current need not to be the same in each of the branches. A defective or disconnected computer in one part will not stop the flow of current to the remaining branches in the circuit. So what they are saying is that for that bottom one that is known as the parallel circuit, if there is a wire that is damaged, then definitely that can cause a disruption in the supply of electricity. Here we have another scenario. So most of the electric wiring in the home is done in parallel, so that when one appliance is off, the others will stay on. So instead of drawing the physical component in the circuit, you can use symbol which represent the components. Bring out this. Right, so these are the symbols, so definitely persons must know these symbols in terms of their names and what they represent. So bulb, for example, there is a symbol for bulb. So if you're drawing or constructing a circuit, you don't necessarily have to write out the word like bulb, because there is basically a symbol for it, and the symbol come with a meaning. So what you're seeing here, so we have two, we have one with the X and one without X. So when you see that, it means that it gives out heat and light when current passes. The second symbol represent a bulb. The second symbol represent a bulb in a holder. So the second representing. So this one now, the switch now. So once you see any drawing look like this, it is that showing a switch, and they are saying that the switch used to turn current on and off. Moving down with the symbols, you see that one that is known as you have cross and you have join. So usually made up of copper, which is a good conductor, and installed with plastic wires that connect different parts of the circuit are often made with done with a dot. So these symbols, so let me send it in the WhatsApp group of persons. Definitely, when I send it in the WhatsApp group, because persons definitely need to know those symbols. Alright, so post it. Alright, so you already have a perfect example in terms of showing a circuit and showing the things of a circuit. Alright, so we have the battery. So of course this sign represents the battery there. That represents cell. So you can, for CXC purpose, you can be given this diagram at the top there. And then now you need to draw an electrical diagram showing everything on the top there. So it's like a plan. So definitely I have the battery. So this is the battery. See the battery up there. And then from the battery, from the battery you have the cable. So here it is. So here is the cable right there. Definitely this represents the switch. And we have two bulbs there. So these are the two bulbs. So and I mean basically that's it for that circuit. Not really a complicated one. That's a simple series circuit. Now back to the right hand side, and we have a complex, really much more difficult parallel circuit. So again, you have the two bulbs, as these two represent bulbs. You have a battery. This represents the switch. Right. So once we're met face to face, then definitely we'll do an experiment on electricity. Right. So once we meet again, we'll just do an experiment on electricity. Let me see.